हेलो स्टूडेंट, आज पढ़ेंगे हम इलेक्ट्रिसिटी की एनसीईआरटी एग्जाम्पलर प्रॉब्लम्स। तो चलिए चलते हैं पहले क्वेश्चन पर। अ सेल, अ रजिस्टर, अ की एंड एमीटर आर अरेंज्ड एज शोन इन सर्किट डायग्राम ऑफ फिगर 12.1. द करंट रिकॉर्डेड इन द एमीटर विल बी। तो हम तीनों सर्किट को वन बाय वन एनालाइज करेंगे। जैसा कि हम पहले सर्किट की ओर जाते हैं। अ, इसमें एक वोल्टेज है, और एमीटर है और रेजिस्टेंस है और एक की है। सेम केस फिगर 2 और सर्किट 2 में भी है, और सेम केस इज आल्सो इन सर्किट 3. सो द current will be same for all the cases. तो चलिए चलते हैं दूसरे क्वेश्चन की ओर। In the following circuit, figure 12.2, heat produced in resistor or combination of resistor connected to a 12 volt battery will be. So हमें मैक्सिमम हीट प्रोड्यूस कैलकुलेट करना है। इन दूसरे शब्दों में कहें तो हमें मैक्सिमम रेजिस्टेंस कैलकुलेट करना है, क्योंकि मैक्सिमम हीट का फार्मूला होता है I²RT। सो I²RT और वोल्टेज के फॉर्म में V² डिवाइडेड बाई R. सो मैक्सिमम रेजिस्टेंस विल बी so maximum resistance is directly proportional to maximum heat produced. So first, in first case only one resistance is there, so only 2 ohm. दूसरे क्वेश्चन पे चलते हैं तो इस पे 4 ohm resistance are connected in series. एंड थर्ड सर्किट पे चलते हैं तो इस पे 1/2 plus 1/2, that is 1, so only 1 ohm. So in second case the heat produced will be maximum. ये हमारा है थर्ड क्वेश्चन, that is electrical resistivity of given metallic wire depends on. So electric resistivity is लेंथ पे डिपेंड नहीं करती है, ना ही थिकनेस पर और ना ही शेप पर। यह डिपेंड करती है नेचर ऑफ द मटेरियल। सो इसका आंसर होगा डी। ओके, सो ये फोर्थ क्वेश्चन इंटरेस्टिंग है, और इसमें है अ करंट ऑफ 1 एम्पियर इज ड्रॉन बाय फिलामेंट ऑफ इलेक्ट्रिक बल्ब, नंबर ऑफ इलेक्ट्रॉन पासिंग थ्रू अ क्रॉस सेक्शन ऑफ फिलामेंट इन 16 सेकंड भी रफली। जैसा कि हम जानते हैं कि जब करंट आर करंट इज फ्लोइंग ड्यू टू मोशन ऑफ इलेक्ट्रॉन्स। सो करंट का फार्मूला होता है नंबर ऑफ टोटल चार्ज पास्ड बाय इन गिवन टाइम, सो दैट इज Q by T, and that Q is given by electrons. जैसा कि हम इस सॉल्यूशन से देख पा रहे हैं कि टोटल चार्ज जो है 16 कूलम्ब है, और 16 कूलम्ब चार्ज हमें इलेक्ट्रॉन्स से मिल रहे हैं। लेट से वी हैव n इलेक्ट्रॉन्स, हमारे पास n इलेक्ट्रॉन्स है, और उसका चार्ज हमें पता है 1.6 इंटू 10⁻⁻19 कूलम्ब होता है। तो from this equation we will have a 10 to the raise power 20 electrons. आइए चलते हैं फिफ्थ क्वेश्चन पर। तो फिफ्थ क्वेश्चन है कि आइडेंटिफाई द सर्किट इन विच इलेक्ट्रिकल कंपोनेंट हैव बीन प्रॉपरली कनेक्टेड। हम चारों सर्किट को वन बाय वन एनालाइज करते हैं। पहला सर्किट है हमारे पास, हम कोई भी सर्किट अगर प्रॉपरली कनेक्टेड है, इसमें दो चीज़ों का हमें ध्यान रखना होता है कि वोल्टेज हमारा वोल्टेज शुड बी कनेक्टेड पैरेलल टू रेजिस्टेंस, and uh, ammeter should be connected in series to the uh, uh, in voltage and in the circuit. So in first circuit, voltage or battery and ammeter, no, I think I missed. Okay, in first, voltmeter and ammeter both are connected in series, so this is not correct. And हम दूसरे क्वेश्चन की ओर बढ़ते हैं. इसमें जो एमिटर है उसका निगेटिव टर्मिनल से कनेक्टेड है, सो ये आंसर सही नहीं होगा. एमिटर का पॉजिटिव टर्मिनल से कनेक्टेड होना, पॉजिटिव टर्मिनल should be connected to the negative terminal of the battery. And if in third option, so volt, I think fourth one. Okay, so second is properly connected because negative terminal of the ammeter is connected to the negative terminal of battery, and potential meter or voltmeter is connected parallel to resistance. So second is right. And in third case, ammeter is connected parallel to resistance, so it is not right. And in fourth case, the ammeter, positive terminal of ammeter is connected to negative terminal of battery. So चलिए चलते हैं सिक्स्थ क्वेश्चन पर. सो सिक्स्थ क्वेश्चन है, व्हाट इज द मैक्सिमम रेजिस्टेंस विच कैन बी मेड यूजिंग 5 रजिस्टर ईच ऑफ 1/5 ओम. तो हमें मैक्सिमम रेजिस्टेंस निकालना है 1/5 ओम रेजिस्टेंस से, जो कि हमारे पास 5 हैं. तो अगर हमें मैक्सिमम रेजिस्टेंस निकालना है तो हमें सारे रजिस्टर को हम सीरीज में ऐड करेंगे. तो अगर हम 5 रेजिस्टेंस को 1/5 ओम के सीरीज में ऐड करते हैं तो हमारे पास 1 ओम रेजिस्टेंस आएगा. हम सॉल्यूशन देखते हैं. और सेवंथ क्वेश्चन इज, व्हाट इज मिनिमम रेजिस्टेंस विच कैन बी मेड यूजिंग 5 रजिस्टर ईच ऑफ 1/5 ओम. अगर हमें मिनिमम रेजिस्टेंस बनाना है तो हमें सारे रेजिस्टेंस को पैरेलल में ऐड करना होगा. और सो 1/5, 1/1/5, 1/1/5, so on. So we will have 5 times 5, that is equal to 25, and reciprocal of 25 is equal to 1/20 ohm. So that will be the answer. हम एट्थ क्वेश्चन की ओर चलते हैं. सो एट्थ क्वेश्चन इज द प्रॉपर रिप्रेजेंटेशन ऑफ सीरीज कॉम्बिनेशन ऑफ सेल ऑब्टेनिंग मैक्सिमम पोटेंशियल. अगर हमें मैक्सिमम पोटेंशियल बैटरी को कनेक्ट करके प्राप्त करना है तो हमें निगेटिव टर्मिनल ऑफ द बैटरी शुड बी कनेक्टेड टू द पॉजिटिव टर्मिनल ऑफ द बैटरी, एंड सो ऑन. सो हम जैसा कि हम देख पा रहे हैं कि हमारा ये 4 ऑप्शंस में फर्स्ट ऑप्शन में ही पॉजिटिव टर्मिनल इज कनेक्टेड टू नेगेटिव टर्मिनल्स, एंड पॉजिटिव टर्मिनल इज कनेक्टेड टू नेगेटिव टर्मिनल ऑफ द बैटरी. सो द फर्स्ट ऑप्शन इज राइट. हाँ, नाइन्थ क्वेश्चन पे हम चलते हैं. विच ऑफ द फॉलोइंग रिप्रेजेंट्स वोल्टेज. वोल्टेज, देयर इज अ formula for voltage, and relation between work done and voltage is Vi equal to Vit in Vit equal to work done. That is the formula, and I can be written in the form of so Vit सो फ्रॉम दिस फार्मूला हमारे पास मिल जाएगा करंट वोल्टेज इक्वल टू वर्क डन डिवाइडेड बाय आई इंटू टी। चलिए चलते हैं 10वें क्वेश्चन पर। अ सिलिंड्रिकल कंडक्टर ऑफ लेंथ आई एंड यूनिफॉर्म एरिया ए हैज़ has resistance R. Another conductor of length 2L and resistance R of same material has a area of cross section. I think miss there is a mistake. It should be L, not I. And so the formula for resistance is resistivity into length divided by area. तो अगर रेजिस्टेंस दोनों का सेम है और दोनों एक ही मटेरियल से बने हुए हैं तो इस इसका अगर रेजिस्टेंस सेम है तो इसका एरिया शुड बी डबल्ड, दैट इज द केस। सो सी ऑप्शन इज करेक्ट। लेट्स move to the 11th question. A student carries out an experiment and plots VI graph of 3 sample of nichrome wire with resistance R1, R2 and R3 respectively. Which of the following is true? Okay, so V by I is resistance, and V by I is resistance, and I by basically in this case, in this let's analyze all three resistance uh, one by one. Let's move to the first resistance. In that case, when we are when uh, uh, I by V equal to 1 by R. So we can see that when in first case, when we are in all three cases, when we are increasing voltage, current is increasing, so that is obvious. But R1, so this uh, the, this is the slope for R1, R2 and R3. For case R1, it has a maximum slope between IV curve. That mean R1 should be R1 is small, have a smallest resistance, followed by R2 and then R3. So I think a D option should be correct. Okay, yeah. So C option is correct. That R1 is smallest and then R2 and R3. I think there is R3 in between. तो चलिए चलते हैं 12th क्वेश्चन पर। इफ़ द करंट आई थ्रू अ रजिस्टर इज इंक्रीज्ड बाय 100%, assuming the temperature remain unchanged, the increase in power dissipated will be. uh, conclusion. So uh, if we are increasing resistance by 100%, इसका मतलब यह है कि अगर हमारा रेजिस्टेंस लेट से आर वैल्यू का है तो हमारा रेजिस्टेंस 3R हो जाएगा फ्रॉम दैट। एंड पावर डिसिपेटेड का फार्मूला होता है V² by R। सो हमारा जो पावर होगा 3% 300% से इंक्रीज हो जाएगा। अ, चलिए चलते हैं 13th क्वेश्चन पर। The resistivity does not change if the material is changed, the temperature is changed, the shape of resistor is changed, and both material and temperature are changed। जैसा कि हम जानते हैं कि रेजिस्टिविटी एक मटेरियल की क्वांटिटी होती है और मटेरियल की एक क्वालिटी को दर्शाता है। तो अगर हम मटेरियल को चेंज करेंगे तो रेजिस्टिविटी चेंज हो जाएगी। तो हमारा ए ऑप्शन एक गलत है और हम बी ऑप्शन की ओर चलते हैं। द टेम्परेचर चेंज करने पर भी रेजिस्टिविटी हमारी चेंज होती है। तो हमारा जो सी ऑप्शन होगा, द शेप ऑफ रजिस्टर इज नॉट रिलेटेड टू द रेजिस्टिविटी ऑफ द मटेरियल। 14th क्वेश्चन, इन अ इलेक्ट्रिकल सर्किट 3 incandescent bulbs A, B and C of rating 40 watt, 60 watt and 100 watt respectively are connected in parallel to electric source. Which of the following is likely to happen regarding their brightness? जैसा कि हम जानते हैं कि ब्राइटनेस एक पावर को दर्शाता है किसी भी बल्ब का। तो in that case A has 40 watt power and B has 60 watt and C has 100 watt. So C will be brightest among all, and then B and then A. So हम अगर चारों ऑप्शन को एनालाइज करते हैं, ब्राइटनेस ऑफ द ऑल बल्ब विल बी सेम, सो दैट विल बी नॉट करेक्ट बिकॉज द पावर ऑफ ऑल थ्री आर डिफरेंट। एंड लेट्स सी द बी ऑप्शन, दैट ब्राइटनेस ऑफ बल्ब ए विल बी मैक्सिमम। okay, so that is, so brightness of the bulb B will be more than that of A. Brightness of, so B option is not correct because A, the brightness of bulb A will be maximum. In fact, brightness of bulb A will be least. And C option की ओर मूव करते हैं। C option, brightness of bulb B will be more than brightness of that of A. So that is correct because bulb B has watt of 60 watt and A has only 40 watt. So in D option, brightness of bulb C will be less than that of B. So D option is also not correct because in C cases the power of bulb C is 100 watt, that is 100, and this is greater than the power of bulb B, that is 60 watt. So let's move to the next question, that is 15. And in this 15 question, in electrical circuit, two resistor of 2 ohm and 4 ohm respectively are connected in series. uh, to a 6-volt battery, the heat dissipated by 4 ohm resistor in uh, 5 second will be. So we are required to calculate heat generated by this resistance, that is 4 ohm. So the both resistance are connected in the series, so the total sum of resistance will be 6 ohm. So the since the battery is connected is 6 volts, so the current flowing through that entire circuit will be 1 ampere. And the power or heat generated, the formula for heat generated is I square RT. So I is 1 ampere, and resistance is 4, and time is 5, so 4 into 5, so that will be 20 joule. Yes. And let's move to the 16th question, that is an electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. A fuse wire of what rating must be used for it? 16. Let's move to the next question before we will back to the 16th question. I think there is in 17th question, two resistor of resistance 2 ohm and 4 ohm when connected to battery will have same current through them when connected in parallel. uh, so that is not correct, because potential difference between in parallel case, potential difference between both the resistance will be same, and but resistance will be different. So there will be a different current in both the resistance. And let's see the B option, that is same current flowing through them when connected in series. So that is correct, because when both resistance are connected in series, so there will be total of 6 ohm, and the current will be uh, uh, voltage V divided by 6 ohm. So current, that will be the current. And let's see the C option, that is same potential difference across them when connected in series. So that is not the case. The potential difference is I into R. I is same in both the resistance when they are connected in series, but the resistance is different. 2 ohm for the first resistance and 4 ohm for the second resistance. So C is not also not correct. So different P. uh, uh, P is calculated uh, V by formula VI or I squared R. So since there is not written whether they both resistance are connected in series or parallel, but we are required to give right answer. So the B option is correct, right. Let's तो 18th क्वेश्चन है, यूनिट ऑफ इलेक्ट्रिक पावर में आल्सो बी एक्सप्रेस्ड एज, लेट्स एनालाइज all four option one by one. And यूनिट ऑफ पावर इज वाट, और इसे हम वोल्ट एम्पियर में भी डिनोट कर सकते हैं. सो यूनिट ऑफ इलेक्ट्रिक पावर इज आल्सो इक्वल टू वोल्ट एम्पियर एंड किलोवाट आवर. So the option A is correct, that is volt ampere. I think kilowatt but there is a problem with the answer, because kilowatt hour is for energy. तो चलिए चलते हैं शॉर्ट आंसर क्वेश्चन की ओर. तो ये हमारा 19th क्वेश्चन है. अ चाइल्ड हैज़ ड्रॉन इलेक्ट्रिक सर्किट to study Ohm's law as shown in figure 12.6. His teacher told that circuit diagram needs correction. Study the circuit diagram and redraw it after making all corrections. तो हम ये सर्किट को एनालाइज करते हैं और देखते हैं कि इसमें क्या गड़बड़ है. there is a voltage, uh, there is a battery connected to the in series. ओके सो इस डायग्राम में जो हमारा वोल्ट मीटर है, इट शुड बी कनेक्टेड. वोल्ट मीटर हमारा रेजिस्टेंस के पैरेलल कनेक्ट होना चाहिए और एमीटर सर्किट के सीरीज में कनेक्ट होना चाहिए. तो पहला ये प्रॉब्लम है, हम इसे कनेक्ट करेंगे. और दूसरा, इसमें जो अपनी बैटरीज हैं, बैटरीज अगर हम सीरीज में कनेक्ट कर रहे हैं तो निगेटिव टर्मिनल शुड बी कनेक्टेड टू द पॉजिटिव टर्मिनल. एंड बट यहाँ पास हम देख सकते हैं कि पॉजिटिव टर्मिनल is connected to the positive terminal, so that is the problem. Let, 20th question, there is 2 ohm resistance A, B and C are connected as shown in figure 12.7. each of them dissipates energy, can withstand a maximum power of 18 ohm without melting. Find the maximum current that can flow through the 3 resistors. ओके सो हमारा जो पावर का फार्मूला होता है वो आई स्क्वायर्ड आर होता है. जैसा कि हम देख सकते हैं कि जैसा कि हम देख सकते हैं कि यहाँ हमारे पास आई करंट फ्लो हो रही है और यहाँ पास डिस्ट्रीब्यूट हो जा रही है ये सेम करंट I/2 एंड I/2, क्योंकि हमारे पास दोनों ही रेजिस्टेंस 2 ओम के हैं. तो चलिए चलते हैं 22वें क्वेश्चन पर. ड्रा अ सर्किट डायग्राम ऑफ एन इलेक्ट्रिक सर्किट containing a cell, a key, an ammeter, a resistor of 2 ohm in series with combination of 2 resistors for that a resistor 2 ohm is in the series with combination of 2 resistor 4 ohm in parallel, एंड अ वोल्ट मीटर अक्रॉस द पैरेलल कॉम्बिनेशन। हम यहाँ पास देख पा रहे हैं कि वोल्ट मीटर हमारा 4 ओम रेजिस्टेंस के पैरेलल में लगा हुआ है, और इन है 4 ओम का, और एक 2 ओम का रजिस्टर है। पैरेलल कॉम्बिनेशन ऑफ 4 ओम, हम इसे कैलकुलेट करते हैं। तो 1/4 ओम प्लस 1/4 ओम। सो द क्योंकि जो पावर का फार्मूला होता है वो I²R होता है, और रेजिस्टेंस ज़्यादा होने के कारण पावर हमारा उस फ्यूज का बहुत ज़्यादा होता है। सो लेट्स मूव टू द 24 क्वेश्चन। व्हाट इज इलेक्ट्रिकल रेजिस्टिविटी इन सीरीज इलेक्ट्रिकल circuit comprising a resistor made up of metallic wire? The ammeter reads 5 ampere. The reading of the ammeter decreases to half when the length of the wire is doubled 5. हाँ, तो पहला क्वेश्चन पर हम देखते हैं। व्हाट इज इलेक्ट्रिकल रेजिस्टिविटी? इलेक्ट्रिकल रेजिस्टिविटी किसी भी मेटल्स की या किसी भी कंडक्टर की एक क्वालिटी होती है जो एक करंट को रेजिस्टेंस प्रोवाइड करता है, और ये उस रेजिस्टेंस की लेंथ, क्रॉस सेक्शन एरिया पर डिपेंड नहीं करती है। हालांकि रेजिस्टिविटी हमारी टेम्परेचर पर डिपेंड करती है। और फिर उसके बाद हम दूसरा क्वेश्चन देखते हैं। इन अ सीरीज इलेक्ट्रिकल सर्किट कंप्राइजिंग अ रजिस्टर मेड अप ऑफ मेटेलिक वायर, the ammeter reads 5 ampere. The reading of the ammeter decreases to half when the length of the wire is doubled. सो करंट का हमारा फॉर्मूला होता है पोटेंशियल डिफरेंस V डिवाइडेड बाय रेजिस्टेंस R। सो अगर हमारा करंट हाफ हो रहा है, इसका मतलब हमारा रेजिस्टेंस डबल हो रहा है। और रेजिस्टेंस अगर हमारा डबल हो रहा है, इसका मतलब जो लेंथ है वो हमारी डबल हो रही है, क्योंकि जो रेजिस्टेंस का फार्मूला होता है दैट इज रो इनटू दैट इज रेजिस्टिविटी इनटू लेंथ ऑफ द रेजिस्टर डिवाइडेड बाय क्रॉस सेक्शन एरिया ऑफ दैट रेजिस्टेंट। सो हम चलते हैं 25 क्वेश्चन पर, और 25 क्वेश्चन है व्हाट इज द कमर्शियल यूनिट ऑफ electrical energy represent in terms of joules? So commercial unit of energy is kilowatt hour, and so that is basically a power into time, that is energy. So if we write in terms of joule, so kilowatt is 1000 watt into in hour how many seconds. uh, in hour there is 60 minutes, and in 1 minute there is 60 seconds, so 60 into 60, so the total joule uh, is 3.6 into 10 to the power 6. So this is 26 question. A current of 1 ampere flows in series circuit containing an electrical lamp and a conductor of 5 ohm. A current of 1 ampere flows in circuit containing an electrical lamp and a conductor of 5 ohm when connected to 10-volt battery. Calculate the resistance of electrical lamp. Now, if the resistance of 10 ohm is connected in parallel with series combination, what change, if any, in the current flowing through 5 ohm conductor and the potential difference across the lamp will take place? Give reason. तो चलिए चलते हैं 27 क्वेश्चन पर. Why is parallel arrangement used in domestic wiring? So in parallel combination, uh, it provides the same potential difference across each electrical appliances. So that is the reason for doing a parallel arrangement in domestic wiring. uh, but there is a difference resistance for different appliances that makes a different power output for different thing, like for examples bulbs, fan, and different thing. We will see later about 26th question. So 28th question is B1, B2 and B3 are three identical bulbs connected as shown in figure. When all three bulbs glow, a current 3 ampere is recorded by ammeter A. What happened to the glow of other two bulbs when the bulb B1 gets fused? Uh, what happened to the reading of A1, A2, A3 and A when bulb B2 got fused? How much power is dissipated in circuit when all three bulbs glowed together? Potential difference does not get divided in parallel circuit. Okay, so in parallel circuits potential difference हमारा same रहता है. Hence glowing of other will not get affected when bulbs one is fused. So glowing is depend on the current flowing through that bulb, that is uh, I squared r, uh, uh, I squared r, or that is equal to v square by r. So potential difference is same and resistance is same. So the brightness or glowing of the bulb will not get affected when some of the bulbs get diffused. And let's see the second option, that is what happened to the reading of A1, A2, A3. A2, Emitter A shows a reading of 3 ampere. This means each of the A1, A2 and 3 show IA reading. That is And what is the third one? How much power is dissipated in circuit when all three bulbs glow together? When all bulbs glow together, then we can calculate a equivalent resistance given by all three bulbs, that is 1 by R1 plus 1 by R2 plus 1 by R3. And since all three bulbs and or we can use a different formula uh, for power, that is I squared R. And since resultant resistance is 1.45 ohm and current is flowing through this all circuit is 3 ampere, that is recorded by ammeter A. So the total power delivered by entire circuit is 13.5 watt. In another circuit, another set of three bulbs of the same wattage are connected in parallel to the same source. तो हमारे पास यहाँ पास तीन बल्ब हैं और तीनों बल्ब में दो केसेस है। पहले केसेस में तीनों बल्ब हमारे सीरीज पे कनेक्टेड हैं और दूसरे केस में हमारा जो बल्ब है वो पैरेलल कनेक्टेड है। जो ये बल्ब है पूरे सर्किट को रेजिस्टेंस प्रोवाइड करेंगे और हम इस रेजिस्टेंस को कैलकुलेट कर सकते हैं जो इसका पावर वैल्यू है, दैट इज़ 100 वाट। सो अगर हम देखें तो अपना जो किसी भी बल्ब का पावर होता है दैट इज़ गिवन बाय V स्क्वायर्ड R, V squared divided by R, that is the power. And the potential since the power of each bulb is same, so that implies that resistance is also same for all three bulbs. In so in first question, so let's see both A and B option. What they it asking: will bulb in two circuit glow with same brightness? Justify your answer. Uh, uh, in resistance of bulbs in series will be 3 times uh, of a single bulbs. Hence, the current in the series combination will be 1/3 compared to the current in each bulb in parallel combination. The parallel combination bulb will glow more brightly. सो अगर हम बल्ब्स को सीरीज में लगाते हैं तो रेजिस्टेंस है हमारा 3 टाइम्स हो जाएगा, जिससे करंट विल बी 1/3 कंपेयर टू द पैरेलल कॉम्बिनेशन. So since the power formula is I squared R and in this case करंट हमारा डिक्रीज हो गया है 1/3 से, सो हमारा जो पावर है वो डिक्रीज हो जाएगा. दैट मीन बल्ब द बल्ब विल बी not bright as parallel combination. In B of the bulb in series combination will stop glowing as the circuit is broken and current is 0. However, the bulb in parallel combination shall continue to glow with the same brightness. B क्वेश्चन को हम देखते हैं. नाउ लेट वन बल्ब इन बोथ सर्किट गेट फ्यूज्ड. विल rest of the bulb continue to glow in each circuit? Give reason. हम दोनों ही केस को एनालाइज करते हैं. Let's first analyze the series combination. In series combination, if both circuits or both bulb gets diffused, the circuit will be open, so there will be no current, and so there will be no glow. And the second option, that is parallel combination. Uh, in parallel combination, one of the bulb get diffused, but the circuit will be still complete for one bulb, so the bulb will keep glowing. So that is the case with parallel combination. So let's move to the 30th question, that is state Ohm's law. How can it be verified experimentally? Does it hold good under all conditions? So Ohm's law states that at constant temperature, potential difference across ideal conductor is proportional to the current through it. So this is the Ohm's law, that potential difference is directly proportional to the current going through that conductor and the resistance of that conductor. But Ohm's law only valid when the temperature is constant. When, let's say, if we are increasing that or decreasing the temperature, then this Ohm's law will not be valid. We can verify this thing experimentally by plotting uh, uh, voltage versus current, and calculating the resistance from the slope of the line. And we can achieve this by regulating voltage across conductor, and keeping the resistance of the material same. Let's move the 31st question, that is what is electrical resistivity of material? What is its unit? Describe an experiment to study the factor on which resistance of conducting wire depends. So resistivity is an inherent property of conductor which resists the flow of electric current. Resistivity is the in each material is unique. SI unit of resistance is uh, ohm meter, uh, and experiment to study the factor on which resistance of conducting wire depends is the length of the resistance and the cross section of the resistance, that where resistance of any material depends. This is a 32nd question. How will you infer with the help of an experiment that the same current flows through every part of the circuit containing three resistors in series connected to the battery? Okay, so let's see how we can know that uh, the same current is flowing through all resistance uh, when they all are connected in the series. So we will take an ammeter and connect it to in the series, and that will record the current flowing through all these three resistance. And let's move to the 33 question, that is how will you conclude that the same potential difference exists across three resistor connected in parallel arrangement to a battery? So we can conclude this by putting voltmeter and record what voltmeter is saying, and this can also be uh, calculated uh, by by calculating the current flowing through each resistance, and the potential difference is equal to current flowing through each resistance into into value of the resistance, so by which we can get the potential difference across all resistance, and we will find that the potential difference across all resistance is equal. And since the current is distributed in parallel combination depending on the resistance, that the more resistance leads to less current, and vice versa. Let's move to the 34th question, that is, what is Joule heating effect? How can be demonstrated experimentally? List its four application daily life. According to Joule heating effect, heat produced in a resistor is uh, directly proportional to square of the current for a given resistor, and the directly proportional to the resistance of given current, directly proportional to the time of the current flowing through the resistor. So Joule heating says that if we have a resistor of resistance R, and the current flowing through that resistance is let's say I, and let's say the current is flowing for like time t, then the Joule heating is equal to I squared R t. So that is given here, you can see it. And there is a daily life examples from where we can see Joule law heating works. Let's see this water heating immersion rod and connect it to the socket which connected to the regulator. It is important to recall that regulator control the amount of current flowing through a device. So the more current flowing through the water immersion rod, it would generate more heat from this formula. And let's see the uh, another example, that is uh, key. So there are another examples of same Joule heating effect, that is electric toaster and electric kettles. And let's move to 35 question, that is, find out the flowing in electrical circuit given in figure 12.9. Effective resistance of 2 8 ohm resistance in the combination. Potential difference across 4 ohm resistance. A power dissipated in 4 ohm resistor, and difference in ammeter reading if any. Okay, so let's solve one by one. Let's first solve the A option, that is 2 8 ohm resistance. Since we can see that both 8 ohm resistor are connected in parallel, so the total resistance will be 1 by 8 plus 1 by 8 uh, reciprocal of it, so that will be 4 ohm. And what the current flowing through the 4 ohm resistance. So since there will be now two 4 ohm resistance, total will be 8 ohm resistance. So the uh, current flowing through ammeter will be 1 ampere. And let's see the C option, that is power dissipated in 4 ohm resistance. Since the formula for power dissipated is I squared R, so current is 1 ampere and resistor value is 4 ohm, so the total power dissipated will be 4 watt from this formula. And I think there is a problem with the formula, there should be I squared instead of just I. And let's say the D E option, that is difference in ammeter reading if any. And since the circuit is in series, the same current flowing through each element of the circuit, so there will be no difference in ammeter of whether it's A1 or A2. Let's move to the next things if any. I think we covered all the problems from electricity. uh, we left few of them and we will go back and see what there was a problem. Okay, so I think we stuck to 28th problem, that there are three identical bulbs, that is B1, B2 and B3. When all three bulbs glow, a current of 3 ampere is recorded by ammeter A. Okay, I think what happens to, I think there is a little bit ambiguity about what is A1, A2 and 3. I think they also ammeter that records the current flowing through each circuit, each parallel combination. Okay, so let's analyze each option one by one. The first one is what happened to the glow of the other two bulbs when the bulbs B1 get diffused. So in first case, if B1 get diffused, uh, uh, there will be still a same potential difference across B3 and B2, and the resistance is not changed at uh, of whether it's B2 or B3, and the power is given by V squared by R, so there will be no difference in glow of B2 and B3. And what happened to the reading of A1, A2 and A3 and A when bulbs B2 gets diffused? Since B2 gets diffused, so there will be no current flowing through this A2. So in A2 there will be no reading, and B1, B3, uh, since uh, currents now currents gets distributed only in B1 and B3, so there will be more current in A1 and A3 in comparison to the earlier case when B2 was not diffused. And let's see the third problem, that is how much power is dissipated in the circuit when all three bulbs glow together. uh, so in order to calculate that, the power, uh, so power is calculated using two formulas generally, that is I squared R and the other another one is V squared divided by R. So let's see which one works better in that case. uh, so yeah, there is a problem with okay, so yeah, so the total current flowing through the circuit is 3 ampere, and the total potential difference generated by the battery is 4.5 volt. So the total uh, resistance of this entire parallel combination is 1.5 ohm, we can see from here. And so the total power of this entire circuit will be a total current flowing through this entire circuit, that is 3 ampere, and the total resistance that offering this circuit, that is 1.5 ohm. So total power will be 13.5 watt. And let's see which other question we have left. I think we have done all question. There is no other question that we need to look. And, okay, we are done with problems of electricity of class 10s. So thank you.